Hey, everybody. Welcome back to the Agent Insider. I'm your host, Andy Jewell. Thanks for joining me today. I have a guest with me today, Jay Young. Jay, thanks for coming on our show.
Yeah.
And Jay's with Axe Engineering here in Whatcom County. Yeah. So, Jay, I'm just really curious to talk to you about. We met socially, and I was super interested because in insurance, we deal a lot with building ordinance and law coverages and things where someone's doing a rebuild and there's all of a sudden these extra things that nobody thought about. And that's kind of where a big place that you guys play in. Obviously, you're doing new construction stuff too, not just rebuilds. But I was super curious. I was like, wow, you guys have a whole firm that specializes in just stormwater. So I was excited to have you come on and just tell us a little bit about Axe Engineering, how you got involved. Maybe we'll kind of start there. Who is Axe Engineering and how did you get involved with it?
Yeah, no, that's a great place to start. Axe Engineering was started in right about 2016, 2017. And it was started by actually my brother-in-law, who was Aaron Russell. He's the principal engineer over there. And right about the time that he struck out on his own to create Axe Engineering, the stormwater rules changed all across Washington State, and it was good timing for him. And him and I are great friends. We're obviously brother-in-laws. We married sisters. Okay. So yeah, I was watching his business grow at the time, and it was always fascinating to me. And he would always keep me updated on, hey, this is what we're doing. This is where we're growing. This is where things are. This is my plan. I looked at his business plan when he was first starting out. And I was always very interested. But it was fortuitous for him at the time he started in civil engineering. Stormwater was not something everybody needed. It was kind of one of those things that, to be truthful, a lot of the engineering firms, the incumbent ones who have been around for a long time in the area, really didn't want to do. They didn't want to mess with stormwater. They wanted to do gigantic developments, big commercial projects, right, where they could keep, billing hours for, sometimes years on some of these things and keep a good sized staff busy for a long time. Well, when Aaron started Axe Engineering, his mindset was to go into it completely differently, shake up, the tired model of how civil engineering companies had been ran. Lucky for him, right at that time, stormwater rules changed dramatically and the requirements just totally exploded for deeming what types of projects will need stormwater and what ones won't. And it was fortuitous for him. He had an opportunity to sort of take advantage of that niche, and he gobbled up every stormwater design project he could because nobody else really wanted to deal with it. So he became an expert in the area.
So you say the tired model of engineering, like from the outside, most people would go like all engineering is tired, right? Like it's just boring as falls asleep.
Yeah.
But so stormwater, like it is maybe for the outside people, like it seems like why bother with this? It seems like a waste. Like I got downspouts we have. What does that mean when you talk about stormwater systems and stormwater management? What does that actually entail?
Yeah, no, I'm glad you brought that up because that's something we struggle with all the time. It's, answering the question, what is stormwater and why should you care? I think as a company and in our marketing message and just in our message to clients, we always try to respect the fact that like, you don't necessarily have to care so much about what goes into the actual engineering and the actual calculations of what we're doing. It's wonderful when people want to know, but at the end of the day, we provide permitting assistance and we provide that requirement because it is a requirement to get to the core of your question. That's why people should care, not so much about how we do it, the phosphorus filtering, detention, and flow control, and all these fancy buzzwords that we hear in our office all the time, and it makes sense to engineers, but it really shouldn't matter to the average client. I guess at the core of it, it's a requirement. And what it is, in a nutshell, to explain it as simply as possible, is in God's creation, there is a natural process for how water falling from the sky in the form of rain hits the ground and is processed naturally through the environment. What we do as humans is we go in and we change the environment. And we're creating impervious surfaces. That's probably if there's a buzzword anybody catches from today, that's something.
Impervious surface.
Impervious surfaces. So be on the lookout for that. If you're building and that term ever comes up, should be synonymous with stormwater. Anytime you see the buzzword impervious surfaces. So what we're doing is when we're creating those surfaces that it's in the form of, the roofs of our homes, pavement in any form, driveways, etc. That water can't soak naturally into the ground.
Right.
And there's runoff that happens. Stormwater is basically the science of dealing with that runoff that's not naturally going into the ground. It's flowing out in ways that are unnatural to the environment. And the job of stormwater engineers is to figure out ways to deal with that in a calculated way to where it can go into the surrounding ecosystem in a way that's sustainable and makes sense. And more importantly, gets you your building permit.
We do the recurring theme. It's because you have to. That's why you care.
Absolutely.
Yeah. Well, and I think, obviously at the end of the day, that is something that's a big deal. We had, small example, we had a customer, they had a house fire. It was a significant fire. We're rebuilding the house, and the house was originally built like I think it was the early 70s. Mm-hmm. And so it didn't have any concerns of stormwater at all when they built it. And now all of a sudden to get the permits, there is a stormwater requirement. They had to have it designed. They had to tie in their downspouts and all this sort of stuff, which adds extra cost. And then to your point, ultimately, we just had to do it because we couldn't get a permit without it. But I'm just kind of curious if you have some ideas or some thoughts or examples of like when somebody when the stormwater is not planned, like should we be down at, City Hall or at the Capitol with pitchforks saying no more stormwater because this just holds up permitting? But it seems like your example there of how do we deal with that water? What happens when we don't deal with it properly? Do you have some examples or thoughts about what you've seen when it's been mismanaged or hasn't been planned properly?
Sure. Yeah. And I think that's a perfect example that the rules of stormwater management have changed dramatically. For example, we look at, say, projects even in Bellingham, like the parking lot where I guess it'd be Best Buy, that whole parking lot, that's a massive paved surface. Bellis Fair is another great example.
Yep.
When you look around in those parking lots, there's not a lot of catch basins and storm collection systems. The reason why is at the time, it really just wasn't a requirement.
Right. Nobody cared.
No, nobody really cared. And I would imagine there's downstream impacts to that. What they are, I have no idea. But I guess the point is back to that, what we talked about, there are repercussions that have to be considered. When those considerations aren't taken, here's a good example of a project that came our way. Somebody was interested in, having us help them. They had a lot. They were at the bottom of a slope, mm-hmm. right? So they had a pretty good slope, and there was a neighbor, sort of a smaller and much older development at the top of that slope. Well, the stormwater at the time it wasn't really considered. So everybody has downspouts that are going on to, what they call splash blocks. And then it was just like presumed that water would just go into the ground naturally. Well, subsurface conditions, the soil is not the same everywhere. When you hit layers of restrictive layers like clay, like layers where that water just sits in, the term's called, it's perched groundwater, where it really can't infiltrate into the soil any further. Well, it just kind of spreads out underground. And that happens laterally, right? So when it gets to the side of the slope, that water's getting taken over by the forces of gravity. So as you can imagine, in a development at the top of the hill, at the bottom, that water's going to end up downhill. We had a client where it was like they had a small retaining wall that wasn't really great to begin with, but the whole thing washed out.
Oh, wow.
And, it became to a point where there was a small creek that was just developed down the hill, and was coming right through the retaining wall. And it was, they had water in their crawl space. It was a total mess. Right. So yeah, that's probably like the nightmare situation of what can happen when it's not considered.
Right. It's like hydrostatic pressure, right? Water pressure is a huge issue. We had a few years ago, I think it was like 10, maybe 15 years ago, there was a landslide locally down in Oso, Washington.
Yes, I recall.
Where the whole hillside just gave way. And it was water driven, right? It's the water runoff eroding and eventually collapsed. And I don't remember how many homes. I think it was like 100 homes or something like that were lost because they just all slid down the hill. Thankfully, I don't think anybody died in that, thankfully, but it can be real. I had a customer, what you were just describing there. He had it under his, he had a garage slab, and he something wasn't right, didn't feel right when he was parking in his garage. So he had somebody come out and drill some test holes because he was an engineer, and he's like, we need to test all this. And there was a void under his slab. So he had to have the slab removed, backfill. And it's because he was at the base of a small hill and the water was running under the garage and eroding the soil under the garage. And there was nothing supporting his garage floor. So thankfully he felt something off before he just like collapsed his garage. So that's a big deal. We have an office in Bellingham, and it's kind of at it's on Magnolia. And so the water runs down, I believe it's High Street there, off from the Western University. And it's all older development. Like these homes were all built in the late 1800s, early 1900s. And when it rains hard, all that water comes rushing down. It creates a channel. There's a part of the parking lot is gravel there, and it just runs through and creates a channel through the gravel, washes it away because it's running so hard and so fast and so much water because it had no place to go. And it's all running down the sidewalks and the roads, and it's just washing things away. So yeah, to your point, right? Like retaining walls, foundations of buildings, parking lots, like there is actually I don't think we should riot against stormwater stormwater management, because there is significant impacts to property. So while sometimes we sit back and we just get frustrated that this is holding up my permit, there is actually reasons why they have to consider this as things get developed.
Sure.
So
yeah, no, you're absolutely right. It's an old adage is water always wins.
Yeah,
it's a tremendous force of nature. And yeah, there's a balance of respecting what that is, but also I will be the first person to say that being in our firm, we try to really stay at the forefront of what regulations are occurring and what how the Department of Ecology is who ultimately sort of makes the stormwater rules for the state. But then as you filter down to county level, to even municipal jurisdictions of cities, it's interpreted slightly different. So we try to stay at the forefront of what changes in regulations are coming, and trying to keep an eye on that so we can be best prepared to help people through the process of getting those permits as smoothly as possible.
So do you guys typically focus and work in Whatcom County then, like Whatcom, Skagit County, or do you guys go all over the state?
So we have our primary office is in Bellingham. And from there, we handle all of Whatcom County and probably about half of Skagit from that office.
Okay.
At the beginning of what year is it? Wow. 2024, the beginning of 2024, we opened our Snohomish County office, which is located in Arlington. And from there, we're able to handle the southern half of Skagit, all of Snohomish County, and pretty much right down to about Everett. So yeah, we've got a pretty good handle on everything north of Seattle is kind of how we like to say it.
Yeah, well, to your point there, I was like, because it makes sense to think about using local versus using, like somebody online or whatnot, because to your point, there's differences of interpretation. So you could have the same regulation from the EPA, and then it's going to be interpreted slightly different by one state versus another state. And then inside of that state, one county versus another county. And then inside of that county, one city versus another city. So by the time you boil it down, it could almost look very different from what you're doing in Seattle versus for stormwater management versus what you're doing in Ferndale.
Yes, 100%. And even right down to the terminology and nomenclature that the reviewers will use. It's very interesting. Down in Snohomish County, they're called drainage plans.
Oh.
Whatcom and Skagit, they're storm reports. So even just very simple, nomenclature, it can vary. But we find that even year to year within the same reviewers, we're finding they become hyper-focused on different aspects of stormwater. And we do have special stormwater districts here in Whatcom County. My favorite example is the Lake Whatcom watershed.
Yeah.
Big impact, right? So that's Bellingham's reservoir for drinking water, is Lake Whatcom.
Yeah.
So,
what do you think about that next time you see all the kids swimming out there?
Yes, exactly. Exactly. And, as you can imagine, the regulatory guidelines are going to be stricter there. And they certainly are. And there's more hoops to jump through. And it can get a little bit trickier, but for a company like us, Lake Whatcom watershed is actually one of our specialties.
Right.
So
yeah, I could definitely see that if you know it, because you understand the typography. What did he call it? Topography? Is that the right word?
Topography, like
Thank
the
you.
land.
Yeah. Like you understand how that's the land's flowing. You understand what the regulatory environment is and what the inspectors are looking for and what the reviewers are looking for. So to your point, right? It could even be that somebody could submit a plan that would actually be the same as your plan, but it's worded in a way that doesn't fit the system, doesn't fit how they understand it should look and what the wording should be on the documents. And so then you get pushback from them versus the stamp of approval.
That's correct. It's all about, when we put together a storm report, and it's going to be submitted to say, City of Bellingham, let's say. The amount of City of Bellingham storm reports that our office submits every year, I think we're doing quite a bit more than any of the other local firms. So we develop a relationship with the reviewers. They know that when they see an Axe Engineering storm report, it's going to look a certain way. Or, Whatcom County, when we submit to the county on behalf of our clients, they know it's going to look a particular way. We keep internal tabs on reviewers, like what their focuses are, within our office. So we can make sure that we're just constantly adjusting and making sure we're giving it to them the way they like to see it to make the process as smooth as possible. And that's probably the number one value we can provide to clients is it is a niche within the industry of civil engineering.
So you guys don't do any other civil engineering. You just do storm.
Oh, we actually do.
Oh,
yeah.
Okay.
So outside of civil engineering, there's quite a bit that goes along with civil engineering. And it's everything from grading plans. If you're going to, if you have a lot that's sort of got dips and the topography is uneven, but this is going to be a commercial property. Well, it's going to you need a fill and grade permit. That's a large part of civil engineering, what we do. I would say if you're putting in, if a developer is putting in a neighborhood of multiple lots that are all going to need utilities going to each lot, we do that as well for subdivisions. That's a very large part of civil engineering. Each one of those lots, incidentally, needs stormwater as well. Right. But they also it all needs to be tied in with a really great looking report that shows how you plan to get utilities, water, sewer, electric, everywhere, what the road situation, setbacks, all of that looks like. That's a big part of civil engineering. We do all those things as well, including structural engineering as well. We do have a division for structural too.
Oh, wow. So you do structural, which is going to be like designing the building, the loads.
Working with the architects and building designers. We take their architectural sheets, and then our structural engineers will take a look at it and, calculate, load bearing walls, what's necessary for the engineering for that. So it's built solid and it meets building code.
Right. Yeah. It's, engineering is, here I say some people go, why bother with engineering? Right. Like we can figure out how to slope a property. Water runs downhill. I get that. Why engineering? I guess. What would your answer be? Like, why bother with a civil engineer? Why bother having somebody else versus besides the permit? But I get that part, right? Like the government's not going to give you your permits if I just draw it up on a napkin.
Yep,
but
that's right.
Do you guys see like people who have done things that you're like, wow, that was definitely not an engineer who designed that versus like, this is how engineers approach it?
Yeah, it's a great question. And I think myself as a non-engineer working for an engineering company, I get to support the engineers who really are they love the math. Mm-hmm. They love the math and they love the intricacies of putting it together in a way that like is optimizing a system. And just, squeezing out every bit of efficiency, versus budget. They love that. For me, when I came into it, I was constantly asking myself the question, because I do our business development, right? My job is everything that's customer focused, client facing, and then general air traffic control for the office. And I figure if I'm doing my job great, the engineers get to have their headphones on and they get to be at their workstations crunching numbers and doing the math. If I'm doing my job well, they get to stay doing that. So I in the first couple of years of being at Axe, I was always asking my question, why do we do this? So, what's behind this? And what the most simple common denominator that I've been able to boil it down to is engineering is the math that sort of proves your theory of why you should be able to do something, right? It's just putting numbers to it.
Right.
Because I think you're right. I think anybody could draw it on the back of a napkin, say, well, we know about this much water is going to come down here. We plan to, shoot it out into a pipe here and then send it that way.
Right.
Right? Like, not necessarily the case. The county's going to want to see an explanation of why that works. And it all comes down to calculating things with models to show mathematical models that X amount of square footage of impervious surface is going to generate at an average of X amount of water that comes off of that surface. And what do we do with it? And how do we know that like the system we're putting into isn't going to overwhelm the downstream capabilities of whatever conveyance that it ties into?
Right.
Or if our goal is to simply let it infiltrate into the surrounding, landscape, how do we know that like it's going to be able to? So we work with soils and, soils testing engineers who come out, they do core samples, and we, our guys and gals in the office they love that stuff.
Yeah. It is a different way of thinking. I think that's like you put a nice bow on it. It's just like engineering is the math, the numbers behind why something works. Somebody could design something and it does work fine, but sometimes it wouldn't work fine because you didn't know the volume that you had to deal with.
Absolutely. And I think that's maybe structural engineering and architecture is maybe even a more physical representation of that. To look at that same thing, I look at let's think about cathedrals that were built in the Middle Ages. Incredible leaps of technology in building design and just the way things were built. Massive leaps were taken. And we look at those structures, many of which are still standing today. But, nobody sees the ones that didn't work.
Right. There were ones built that didn't last.
Absolutely. I think they call that survivor bias or something like that. Yeah, there's a term for it, but it's true. Only the best ones are still standing.
Yeah.
But it kind of goes to show like, nobody was engineering that. Nobody was crunching the numbers to know what the actual load bearing capacity of a lot of these highly intricate arches were supporting. A lot of it was trial and error. And at the end of the day, I think they were forced to err on the side of over-engineering.
Right. Because they didn't know.
Right. So you would simply overbuild something with the intent that bigger must be better.
Yep.
We know that we built this wall, it cracked here, so we need to support it in a way that's like this. A lot of trial and error.
Yeah.
And that's, centuries and centuries that was built upon. Now, we have the advantage of mathematical models to be able to extrapolate what loads be how loads will be carried. We've got a lot more knowledge about it. And truthfully, the math is what supports it, because we know tensile strength of certain building products and all that jazz. It's there's an interesting sort of taking that model. There's very interesting correlations when we look at engineering in the world of stormwater. It's kind of the same thing. We know it works and we just apply it. But instead of over-engineering things, we apply math to it and then do what we call value engineering to say, you could do it this way. And it would be very expensive for construction, but it's really cheap for us to engineer because we just max it out.
Right.
What we try to do at Axe Engineering is ride that balance of what we call value engineering. It's going to take us maybe a little longer to figure this complex problem out. But what it results in is in construction costs for the client, it's going to be a lot more affordable on the back end.
Right. Right. Yeah. Just building bigger and better building bigger isn't always better.
Yes.
Right.
100%.
Yeah. But it's the way my dad used to build. He was like, if one 2x4 work, we'll use two 4x4s. Right.
Must be better.
Right. Yeah. And it holds up. It's ugly as heck, but it holds up. I was just thinking about that. We just went on a trip. My wife and I went on our 25th anniversary. We went to Scotland because her mom was born in Scotland. And so it's we went and spent 10 days in Scotland touring around. There's castles everywhere and cathedrals everywhere. And you're right. There's some that are just ruins. There's some that are just you could see the outline of the foundation and that's all that's left. Some are completely still standing and others in, various ways, they're there, but the roof is gone or whatever. And it is amazing to your point. There's a difference in how they were built. And there wasn't a uniform building codes, which sometimes we get really frustrated with as consumers. Building codes are always standing in our way. On the flip side of it, there is that safety factor of you go, hey, these guys got lucky and it worked fine. And the castle's still here 1,000 years later. These guys didn't get lucky, and maybe that collapsed, within the first 50 years of that building being built. Who knows? But the wall didn't stand up, the roof didn't stand up, the archway didn't stand up. But yeah, it is kind of amazing though to think about too, how people figured out some of that stuff. Some of those archways are amazing.
They are.
It's they span huge spaces and they're dry stacked rocks, and you're like, my goodness, who thought about how to do that?
It's truly incredible. That's definitely on my bucket list to get to Europe and see old stuff.
Yeah,
for sure.
Yeah, it's because it is here we go see something old and it's it's 150 years old. Over there, they're it's not old until it's 800 years old, right? It's 150 years old. Yeah, tear it down. That's ugly new junk stuff anyways.
Mm-hmm. Right. So, yeah, it's just totally different world.
Very different world. Very different world. But the other thing I was thinking about was you were talking is how different engineers think about things than us. So I have two kids in engineering. One's doing mechanical, one's doing electrical. And my son is doing the electrical. I took him with me on a trip last year. And there was some fireworks that they had set off at the end of the night. And I was sitting there just enjoying the fireworks. I was like, this is a beautiful setting. And he leans over and he's like, hey, those fireworks are 1.3 miles away. I was like, what? He's like, they're 1.3 miles away. I was like, what? How do you know that? And he's like, oh, based on how high they are, based on how much time the gap there is, based on the speed of light and the speed of sound and all this sort of stuff. And I was like, wow. I was like, you're a geek. Just enjoy the fireworks.
Totally.
Right. But that is like, they just think about things differently. It is all about math. And it's like, I could measure that. I could have went and we could have walked it out or driven it to figure out that it was 1.3 miles. He's sitting there at the dinner tables and figures it out himself because they just think about things different.
Yeah, they do. And what's interesting is, the driving force of why he figured that out while he was sitting there. Because he enjoys it.
Right.
He enjoyed the process of like calculating that.
Right.
And it is. They have different brains. I do not have an engineer's brain.
Me neither. Hopefully there's no engineers watching us because like they're just a weird breed.
Oh, and they know it. That's the thing. It's and I've come to really enjoy my role supporting them because their minds think completely differently.
Yep.
It's truly a beautiful thing to have people that that think in that way. Because they really just they enjoy what they do.
Yeah.
And an engineer's brain and the way it works, so far as I've been able to understand it, they look at complex math problems as fun, which is great. So I totally don't get it. But they love, like, we do Friday lunches at the office. That's what we do. Everybody gets together and we'll pick a different restaurant in Bellingham and do takeout and have a lunch together, kind of celebrate wins for the week, talk about what's coming up next. But it's interesting how often they want to talk about complex math problems. And it's like, oh, you know what? That's a good one. I'm going to think about that this weekend. Like, I won't.
I forgot it by the time I walked out the door. Yeah,
totally. But they love that. And I think it's very cool. God bless them. They really enjoy that stuff. And I think the other thing that I've noticed about the engineer's brain in my experience of it is they will always be chasing being able to maximize any equation, which I always find interesting. They'll always be looking for, whereas, I don't know, in business, we're always looking at trade-offs, right? Speed versus cost,
right?
A whole plethora of trade-offs that we look at.
Right. Everything's a trade-off.
Absolutely. In the world of engineering, there are like the downside, I guess, of that would be, an engineer's brain is always chasing the most maximized way to perfect a system.
Right.
And what we do in our office is we're always having discussions about, and to my point of how we started the show, the client doesn't always care about that.
Right.
The client is looking at value, and we've assessed that in our office. The biggest value we can provide is simply getting them to their permit in the most logical and efficient way possible. So
full circle, we've meandered to European architect and all whatever, but like the full circle of it is civil engineering, stormwater specifically, but engineering in general is a necessary requirement to get permits to build something. Bottom line. So if you're a consumer, you're like, why do I care about engineering? Ultimately, that's the first and foremost reason that you care about it. Secondarily, like there's repercussions if it's not engineered well, right? Like you do have flooding issues, you do have erosion issues, landslide issues. Like there's a lot of things literally and figuratively downstream when the engineering process isn't done well. But back to the original, you want it for your permit using somebody who's local, using somebody who works with your permitting offices, works with the reviewers on a regular basis, knows the lingo, knows what they're looking for and how to present something to reduce the number of times you get pushed back. Because sometimes people don't think about that, right? Like you can get there eventually if you're using someone who doesn't work well with that district, but how many revisions does it take? And how much time do you lose? Because every time they send you something back to say, this isn't right, fix this. And then the engineering has to go back, re-engineer something or reword something, prepare a new document, resend it, wait for it to be re-looked at. Like you can waste a lot of time just in that back and forth. And then the cost may not be any, like someone's like, oh, I found it cheaper online. Cause that's what we find in every business, right? In insurance, we battle with that as well. Like, oh, I found it cheaper online. It's like, at the end of the day, was it really cheaper?
Yes.
Right.
I'm so glad you touched on that. That's in the business perspective of what we do and how we differentiate ourselves in the marketplace. We've really latched onto that because there is a cost in how much back and forth that happens. And you may get quoted, which is common in, I think, any professional industry where people are billing hours. You may get a really great quote out of the gate, and that's your starting point. And then by the time, there's change orders and there's the cost of billing additional hours for revisions for unknown things, the actual cost can be dramatically higher.
Right.
One way we've found to really focus on providing value is in certain areas that we know in and out. And we do so many, I think Sudden Valley would be a great example. Sudden Valley, it's in the Lake Whatcom watershed. We do a lot of projects there, very specific guidelines that need to be hit. We offer a flat fee proposal, which states that we are so confident in what it's going to take to get this thing to approval. We're quoting you one price out of the gate. And even if there's unforeseen things in it, there's additional comments that the reviewers want to see. They want to see this added. There's a new thing that they're asking for. No additional charge.
Yeah.
We'll get it in, revise it, kick it back out, and be focused on getting you approval as quick as possible for one flat fee. Works wonders to be able to, count on that in your budget.
That's huge. That's something that in the construction world, it's hard to find.
Yes.
Anything that's like a flat fee, because there's always things that can come up, right? And I get that. But to the point, right? If you do it so many times, this is not the first time you've done a plan for somebody in Sudden Valley, in the Lake Whatcom watershed. So you guys know what that takes. You know what it's going to be. So there's not going to be the surprises. So that flat fee might seem, if I'm somebody and I'm like, oh, I've been shopping around and I went online, I got a quote from xyzengineeringfirm.com and they can provide me this as well. And they're saying that they're going to do it for me for, 10% less than your flat fee proposal. But if theirs is not a flat fee proposal, the reality is it's going to cost you more in the end of the day, because there is going to be back and forth, because they haven't worked with the city of Bellingham and they haven't worked in the Lake Whatcom watershed 1,000 times already. And so there's going to be stuff that they miss, and there's going to be time loss, which is going to delay your project. And there's a cost of delayed projects, and there's going to be more added fees at the end of the day. So you're not going to save that money. You're going to spend more money than approaching somebody who's done it 1,000 times.
Yeah, I couldn't have said it better. You're exactly correct.
Well, I appreciate the time. So I'm just going to recap one last time just to make sure that I'm hitting on things. So advantages of working with somebody local, somebody who works in your districts and works in your counties all the time. I imagine you would probably tell somebody if they're in Eastern Washington in a different watershed and they're like, hey, can we get a proposal from you guys? And we're going to get a proposal from the local guy who's done 1,000. You probably say, you should probably work the local guy.
Absolutely.
Yeah. So work with somebody local, because they're going to know what you need. They're going to get it done fast. They're going to get it done right. And it's going to cost you less money. And then work with an engineer, because you need your permits. And then secondarily, there's downstream issues when the process isn't done well. So there is a reason behind it, even though it's frustrating. So it does help create less problems later. So, so thanks for joining me. I appreciate it. We're going to do a next segment is our after show, where we're just going to talk about some other things. I want to talk about like how you got into this position, kind of your career journey, about your music, because we talked about that a little bit before, that you do music recording and you've done podcasting before. So I want to kind of delve into a few of those things a little bit more. So stick around, guys. Join us next time. I'll be next week. If you have questions in the meantime, feel free to send us an email at theagentinsider@gmail.com. Otherwise, until next time, we'll see you later.